All right, let's jump right in. Today, you're not just going to watch, you're going to be a cybersecurity intern dropped right into the Security Operations Center, or SOC. We're going to walk you through what a real-world project looks like, step by step, showing you exactly what it takes to defend a company from a pretty nasty cyber attack.
So, picture this. It's your first week on the job. The alerts are flashing, the pressure is on, and your manager just handed you your very first high-stakes assignment. You ready for this?
Here's the setup. You're an intern at a cutting-edge financial technology company, which, makes you a massive target for cybercriminals. Your mission is to get your hands dirty and defend against an attack that is happening right now. This isn't just a drill. This is what a day in the life of a SOC analyst really feels like.
And they're not starting you off easy. Nope, you're being thrown right into the deep end to deal with something called a multi-vector attack. So what in the world are we about to face?
A multi-vector attack is basically when a hacker throws everything but the kitchen sink at you, all at once. The best way to think about it is like a magic trick. They create this huge, noisy distraction over here, say a massive DDoS attack, so that you're not paying attention while their other hand is quietly picking the lock to your server room. The whole point is to create chaos and hide what they're really after.
And if you're thinking, oh, this is just a training scenario, think again. This stuff happens in the real world constantly. We've seen it with banking APIs getting slammed with a DDoS to cover up a breach. The famous Colonial Pipeline attack. That started with a password hack and led to chaos. And the Capital One breach was a textbook case of an attacker finding a simple mistake in their cloud setup. So yeah, the skills you're about to practice are absolutely essential out there.
Now, to stop an attacker, first you have to learn to think like an attacker. So, it's time to put on our red team hat. In a safe, controlled lab environment, your first job is to actually launch the same kind of attack you're supposed to prevent.
To really get inside the attacker's head, you have to follow their playbook. First, you do a port scan with a tool like Nmap. That's like walking around a building and checking all the doors and windows. Then, you'd use something like Hydra to just try and guess the password over and over again. While that's grinding away, you'd launch that noisy DDoS traffic for misdirection. And if you get in, you'd start poking around the cloud, looking for the good stuff. Every one of these steps leaves a digital footprint, a breadcrumb, which is exactly what you'll need for the next phase.
Okay, attacker hat off. Time to switch sides. Now you're the defender, the blue team. Your job is to become a digital detective, to sift through all the evidence at the crime scene and piece together exactly what went down.
And this is where it gets interesting, because each part of that attack leaves a very specific clue. The port scan, that's going to show up loud and clear in your firewall logs. The brute force attempts, you'll see thousands of failures in your authentication logs. The cloud exploration, that leaves tracks in your CloudTrail logs. And that big, flashy DDoS attack, it makes your intrusion detection system light up like a Christmas tree. Your job is to connect all these dots from all these different places to see the big picture.
Okay, so finding the attacker is one thing, but proving it, that's a whole other ballgame. In a real SOC, there's a golden rule. If it isn't documented, it didn't happen. Professional reporting is everything. It's for legal evidence, it's for the next person on shift, and it's for making sure this doesn't happen again. So let's look at what you'd actually have to write up. Your first deliverable is the attack chain map. This thing is awesome. It basically tells the story of the attack from start to finish. You connect each stage, from the first little recon mission all the way to messing with the cloud, to the specific technique used, and, most importantly, the exact log that proves it happened. This is how you build an airtight case.
Next, we've got the evidence table. Think of this as your detective's notebook. It's where all the nitty-gritty forensic details go. Every single shady event gets a timestamp, a source IP, what happened, and what you did about it. And check out that last column, action. This is key. It shows you're not just watching things burn, you're an active defender who's taking steps, like blocking an IP address to stop the threat.
So after all that work, how would your manager actually grade you? Well, it's not just about getting the right answer. The technical stuff, understanding the attack, digging through logs, coming up with a defense, that's the bulk of it for sure. But look at that. Documentation and professionalism together make up a whole quarter of your evaluation. It proves that communicating what you found is just as important as finding it in the first place.
Once you've simulated the attack, you've analyzed the clues, and you've documented your findings, mission complete. You did it. But the real prize here isn't just finishing the project, it's the skills that you walk away with.
Just think, by the end of this single project, you've picked up a ton of resume-worthy skills.
You now get how attackers use layers to hide. You can literally reconstruct a crime scene from digital logs. You know how to use basic defenses like a firewall rule, and you can write up a report like a pro. That's a huge step forward in your career.
And with all that, you've basically unlocked a new achievement, Multi-Vector Defense Operator. And that's not just a fancy title. It represents real, tangible skills in log analysis, cloud security, network defense. You even touched on the MITRE ATT-CAK framework. Seriously, congratulations. You survived your first day. So we'll leave you with this to think about. In that whole chain of events, which part do you think was the quietest, the sneakiest, the absolute hardest to spot? And looking ahead, how could newer ideas like zero-trust architecture or AI-powered tools help an analyst find that needle in the haystack even faster? The threats never stop evolving, which means we, the defenders, can't either. Thanks for joining me.